Kia ora, hello, 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 you're This Way Up and I'm SimonMorton. Today, location, location, location. We're tracking wheelie bins in Christchurch, then a brief history of GPS and a curious tale about a glitch in internet mapping that means over 500 million devices point to one home in Kansas. It's become a digital hell. And before we go, news that turbulence is on the rise. The rate of serious mid-air turbulence on planes is increasing, and we'll find out why. Now, you can email us, thiswayup at radionz.co.nz, or you can send us a tweet at UpThisWay. We're at UpThisWay.
Good morning, everyone, and thank you for joining us today. Before you make yourself comfortable, please take a moment to stow your bags securely. Place small bags under the seat.
Turbulence is always regarded as one step before disaster. So when the pilot says there'll be a little bit of turbulence just on takeoff, they expect to crash and die. The industry just doesn't realise the emotional impact the word has. Now, if the pilot, and some of them are good at it and some of them are doing it, the pilot say there's a few bumps just because we've got some cloud layer there and it'll be a couple of seconds and we'll be through it. That's no big deal. I can deal with bumps. Turbulence means death.
I thought that the air and the elements were like pounding the plane, you know, and forcing it to do stuff. When it's using all of that to fly.
It's not much more than 40 years since flying could be said to have begun in New Zealand. In those 40-odd years, we've come a long way.
Good morning, ladies and gentlemen. A very warm welcome aboard the Delta 4062 Auckland. My name's Eric.
News that the rate of serious mid-air turbulence is increasing will not be welcomed by many passengers or by the airlines themselves, with estimates that in the US alone, damage, delays and disruptions caused by turbulence cost more than $500 million every year. A few months back, we went on a fear of flying course and found out that if you're a nervous flyer, turbulence can really freak you out. You can listen to that story, including the final flight that we did in 100k winds. It's on the RNZ website right now. Paul Williams from the University of Reading studies the air patterns that cause turbulence.
I know of one case in which a plane suffered quite serious damage mid-flight. In fact, one of the engines became detached and fell down to the ground. This is very rare. It happened once during a clear air turbulence encounter over the Rocky Mountains in the US. And even so, the plane still managed to land safely. It was actually a cargo plane rather than a passenger plane. That almost never happens. I mean, we know that something like less than 1% of the atmosphere contains significant turbulence at any one time. And I can give you the injury rate. We know that for every 1 million planes that take off, there's only one person seriously injured by turbulence. So it really is a 1 in a million kind of event.
Although it sounds as if the trend is very much upwards. I mean, the data is suggesting that the incidence is increasing quite severely. In fact, there's one stat I saw, the US Federal Aviation Association said that it had doubled between 82 and 03, and this was taking into account the fact that there are more planes flying.
Yeah, that's absolutely right, Simon. We know actually that since 1980, the number of serious injuries caused by turbulence has actually increased by a factor of 5. Now, as you've suggested, part of that increase is due simply to the fact that more of us are flying these days. So if you have more people in the air, then it stands to reason that you would get more injuries caused by turbulence, even if the atmosphere wasn't becoming more turbulent. But even after we've corrected the statistics to account for that growth in air travel, there's still been something like, as you said, a 100% increase in the number of injuries. And we're accumulating more and more evidence over time that increase may be associated with climate change.
Why would climate change and a rise in temperature lead to more turbulence at altitude?
I mean, the reason is that, of course, the carbon dioxide that we're putting into the atmosphere is changing the temperatures, and that's happening at ground level, and that's the famous global warming that we hear so much about. But actually, the CO2 in the atmosphere is very well mixed, so it gets transported and mixed to very high altitudes on quite short timescales. So it gets mixed up to flight levels, 30 to 35,000 feet, and it's changing the temperatures up there as well. And the particular way that the temperatures are changing at those altitudes is causing the jet stream to accelerate. And the reason behind that is that there's a very delicate balance between the temperature patterns and the wind patterns. And what that means is that if the temperature patterns are changed for any reason, as we are doing through our CO2 emissions, the consequence of that is that the wind patterns are changing in response in order to maintain this delicate balance that exists. So that's the link really from CO2 to temperature changes to changes in the jet stream wind patterns.
Right, so when the plane is actually buffeted and when that load is put on the plane, what's happening?
The plane is usually moving up and down rapidly, and as I say, those vertical motions, if the turbulence is intense enough, the vertical accelerations can exceed 1g, in other words, 1 times the strength of gravity. So it's upward and downward, random, chaotic, what we would call eddies or vortices, basically swirling motions in the atmosphere. It's a particular kind of wave that you can sometimes see actually in clouds. So that's the one time when it would become visible, is when the humidity is just right to expose these. Sometimes you see stripy waves in clouds, and that's the same kind of instability that's causing clear air turbulence, except that it's normally invisible, and it's these random turbulent motions just exerting forces mainly on the wings of the plane, pushing randomly up and down, and passengers will report a sensation a bit like a roller coaster ride, with that stomach lurching kind of feeling when the roller coaster goes on the downward plunge.
Although it is good to know and good to remind people that planes are actually built to withstand these forces, and because the whole plane, as you said there, it's a little bit like being in water. It's not as if that force is being specifically placed on the fuselage or on the wings, is it? Yeah, that's right, and it's important to reassure your listeners. I mean, maybe some of your listeners are heading to the airport right now listening to your show, and I wouldn't want to worry anyone. There's the old cliche that you're more likely to be injured actually on the way to the airport than you are in the sky in the plane, and the statistics certainly back up that turbulence is very rare. The plane is built to withstand turbulence. I've seen tests done on planes where they subject the wings to very strong forces, and the wings really they're very flexible, and they'll bend right the way up. They don't snap, they bend. So the planes are really built to withstand even the strongest turbulence that any plane has ever encountered. So fear not. But it's an interesting challenge that we have. We have clear air turbulence, i.e. you can't see it with the naked eye, and yet we are so good these days at predicting the weather, and we have so many different sensing technologies available. Can't we just predict where this turbulence is likely to occur and say to the plane, stay out of that area?
Well, we do that. There are turbulence forecasts that are done every 6 hours for global airspace, and these forecasts are made available to the airlines and air traffic controllers, and they certainly are used in flight planning. The problem is they're not as accurate as we would like. They've got an accuracy of something like 75 to 80%. So they're right more often than they're wrong, and they are useful and they are used in flight planning, but there is that 20 to 25% extra accuracy that we could, in theory, squeeze out of these turbulence forecasts if we had a better understanding of turbulence, if we had more research investment into it. So there's still more work to be done, really, on improving these turbulence forecasts.
What about detection? Couldn't you have some sort of detector that monitored airspace, say, a kilometre ahead or 500 metres ahead, and then the plane could respond?
Yeah, there are some ideas along those lines. It's the same principle that the radar on board the plane works. It emits radio waves and looks at the reflected signal, and that allows the plane to detect clouds ahead. There is a similar idea that has some promise, at least, to be able to detect clear air turbulence. And actually, instead of using radio waves, it's using ultraviolet light. And it turns out that's the right kind of light to use. It will go ahead of the plane and then be reflected from invisible density perturbations ahead of the plane. And by analysing the reflected light that comes back to the plane, it's possible to detect, in principle, this invisible clear air turbulence. And I've seen some test flights with some very promising results, actually. But the problem with this technology is that it's very expensive. And it's been estimated that it would cost more to fit a plane with this technology then the airline would save from the avoided turbulence. So that's partly why we haven't seen this technology being rolled out yet. But as we go forward in time and the technology becomes cheaper, and potentially as we see more encounters with turbulence as the climate changes, we might well see this technology rolled out across fleet of aircraft. And then really clear air turbulence encounters could, at least in theory, be consigned to the history bins. Many nervous flyers would welcome that, I think.
And in the meantime, Paul, what's the advice to the frequent traveller? Stick your seatbelt on and keep it on?
Absolutely. Keep that seatbelt fastened. I've had a look at the statistics, and people who keep their seatbelt fastened are almost guaranteed not to be injured. It's people and flight attendants who are moving around the cabin. When this invisible turbulence comes out of the blue, those are the people who suffer the serious injuries. If you keep your seatbelt fastened, that's the number one thing you can do to virtually guarantee your safety.
Cheers, Paul. Paul Williams from the University of Reading.